Hi guys, welcome to the fourth part of the building series of the 737-800. In this video, we're gonna see how the electronics work in my airplane so that you can actually apply this to your airplane if needed. So yeah, I hope you enjoy the video. So in my airplane, the power source is a LiPo battery. I used a 4S battery with 6500 mAh, which is enough to power the entire airplane. The connections are made with wires that are really big. They're 12 AWG wires, and I used AC5 connectors, which are really good because they have golden connections and they're really easy to connect and disconnect, which makes the work of assembling and disassembling the airplane really easy. So the LiPo battery is then connected to an anti-spark switch PCB, which is used to avoid that spark that you can see when the battery is connected to the main connector of the airplane. This PCB pretty much disconnects the power of the battery even after the battery is connected to the airplane, which means that you could control the power on-off of the airplane through a control interface, which is on the upper part of the airplane, and that makes it easier for the person that flies the airplane to turn on and off the airplane without having to connect and disconnect the battery every time. So the anti-spark switch is then connected to the ESCs. In my airplane, I used 80 amps ESCs, and those ESCs are then connected to the EDFs through 3 wires that are of course connected to the brushless motor. And so the ESCs have 2 different functions. The first one is to control the speed of the EDFs, and the second one, they have a unit inside called UBEC, and that unit is really important because it powers the entire airplane, so lights and servo motors, which is what I used to power the everything in the airplane. There is also another way of doing it, so without using the ESCs to power everything, and it's by using a BEC unit, which is an external unit, so outside of the ESCs, and of course that would have added only weight to my airplane, which is something that I wanted to avoid. Okay, so this is a picture that groups everything I said before in one picture, and now we're gonna see how the rest of the airplane is powered. So we already said that it's powered through the UBEC units in the ESCs, but we're gonna see how it's distributed in the entire airplane. So the 2 ASCs are directly connected to a PCB that I designed, which is a power distribution board, which takes the power from the ASCs and distributes it between all the lights and the servo motors in the airplane. So before seeing how the connection between the power distribution board and the receiver works, we're gonna see how all the servo motors are connected to the main power distribution board and all the other units. So these connections are made with some wires that are composed of 3 small wires. One is the signal, one is the power, and the other one is the ground. So those wires transmit a signal called PWM, and this signal is read by the servo motors, which elaborate that signal, and they go to the position that the PWM is saying. They have a small PCB with a processor that pretty much translates this signal to the position that they have to go to. So the receiver is connected to this distribution board through a big connector, which connects only the signal of the 10 channels that are available on the receiver to the distribution board. And then there is a small wire that goes from the distribution board to the receiver just to power the receiver on so that it can receive the signal from the transmitter. So then there is a small unit called voltage telemetry unit, which is pretty much just sending to the receiver the voltage of the battery. So from ground, when the airplane is flying, you can actually see what's the voltage of the battery, so you know pretty much the level of the battery when it's flying. So the distribution board is then connected to two different units. One is the gyroscope, which is needed to stabilize the airplane while flying, which is really useful for pilots like me that do not know how to fly airplanes, and it may make the job a little bit easier while flying. And then there is the blue box, which is another unit that it's used to control the lights of the airplane and some other small functions, but I mainly used this blue box for the lights and to organize the connections in the airplane. So we can now see how the servo motors are connected to the gyroscope, the blue box, but also the distribution board. So this is pretty much how all the servo motors are connected into in the airplane. So not all the servo motors are coming directly from the distribution board, but some are coming from the gyroscope, for example the ailerons, the elevators and the rudder. And from the blue box we have the landing gears and the flaps, for example, and some others are coming directly from the distribution board. So in my airplane I used three types of servo motors: plastic gears for the weakest parts, then I used metal gears for example a little bit stronger parts, and then I used some heavy duty servo motors to power the two main flaps, which had to have more power than the others because they're big. So almost every single LED of the airplane is controlled by the blue box. The blue box is connected to the LEDs through a really thin and light wire. The LEDs I used in the airplane are different shape and different dimensions, and of course different colors. The only LED that is not controlled by the blue box is the landing gear light, which turns on and off every time the landing gear goes up and down, which I'm gonna explain later. So in the airplane there are many of these controller PCBs. They are used for different functions. For example, it's used to invert the signal of the servo motors so they turn in the opposite direction. Then they're used to reduce the speed of the servo motors, for example in the flaps and in the spoilers. And they're used to control the landing gear sequence and the door. The landing gear sequencer is done by using those controller PCBs. In particular, there are two. One controls the nose landing gear sequence, so the opening and closing door and the landing gear retraction or extension. And the other one, it's used to activate and deactivate the steering when the landing gear is retracted or extended, and also the gear light, which turns on and off every time it goes up or down. So the last two PCBs that are in my airplane are those connector PCBs that I designed. They're used to have only one connector when you have to assemble and disassemble the airplane, which makes it easier for that step, of course, because you need to connect only one connector instead of all the servo motor connectors every time, which makes it a lot easier and faster. So last but not least, we have the control unit, which is situated in the same spot where the battery is, and that's really important to control the airplane when it's on the ground. It has 4 switches. 3 of these switches are needed to turn on and off the anti-spark and the 2 ESCs. And then there is a small switch that is used to turn on and off a battery level display, which is connected to the same connector of the battery level unit that I said that was connected to the receiver before. So this one here, it's needed on the ground. For example, if you need to see the battery level, you turn on the switch and you can see the battery level directly in the control unit. So this is all the electronics in my airplane. I hope you understood a bit more how my airplane works. If you have any questions, you can ask them in the comments. I will be really pleased to answer them. And yeah, I will see you in the next part, which is probably gonna be the last one, I would say. Maybe there's another one before that, but still, yeah. The airplane is almost finished. I hope you enjoyed the building. So yeah, please consider to support my channel by subscribing and leaving a like if you like what I'm doing. And yeah, I will see you in the next video. Bye guys.